Hi everybody, welcome to Mr. Carroll's classroom. Today we're going to learn how to graph some trig functions, so let's get started. Alright, so the first thing that we're going to do is we're just going to explore the unit circle, or at least just have this unit circle up here. And I think what I'm going to do is I'm just going to turn this little triangle on here because our trig functions that we're going to concentrate on today are going to be 3 out of the 6, and those are the main 3, which are going to be sine, cosine, and tangent. And as we know, the sine is actually the y value of any one of these reference triangles where we are plugging in an angle, right? So when we, and actually let me bring this up here, when we go ahead and start graphing these on a Cartesian plane, or an XY coordinate plane, along the x-axis, we're actually going to be plotting the angle as it goes around. So we're going to start at the initial side of 0 right here, x value of 0, or a theta value of 0. I'm going to use theta just because it's usually what we use for angles, but it could be x, or it could be any variable name actually. But anyway, so we're going to start at 0, and then this thing's going to rotate around, okay, through 360, and then actually even beyond 360, and it's actually going to go in the negative as well. So negative 0, negative 1, negative 2, negative 3, right, all the way through negative 360, and keep going on to the left as well. So that's going to be our what we call our x-axis, or our horizontal axis. It's going to be the measurement of that angle. And by the way, we have 2 different units for this. We could do it in degrees, or we can do it in radians. We typically do it in radians, but we'll probably do it both today. Anyway, and what is going to be plotted in the y? Well, it depends on the function that we're graphing. So if we're going to do the sine function, then if I turn this on, then you can see here that the y value is going to be whatever pops out from the sine of theta, or x, or whatever you want to call it, the sine of the angle. Okay, so that's going to be the y. If we're graphing the cosine, okay, then along the vertical axis will be the whatever pops out from the cosine of that angle. Tangent is going to be whatever pops out from the tangent of that angle. Okay, all right. So before we go ahead and start graphing on this thing, I do want to bring up Desmos really quick, just to get a feel for what this is going to actually look like, okay? Because believe it or not, graphing these it's actually pretty easy once you have an idea of what these functions look like, okay, and what everything means. All right, so let's go ahead and we'll bring this up here. All right, so here we go. All right, so what I have in front of me right now is a unit circle. And if I hit the play button here, let this thing run for a second. Okay. The point that has moved from, along the horizontal axis, our angle of 0, and I really wish there was a line right here. I should probably add that in. But anyway, the terminal side is from the origin to this point right here. Okay. And we have a lot of different, and let me actually advance this just a little bit more. Okay, so we have a lot of different line segments that we can measure. So for example, related to this point, the x value of this point is how far we've traveled from the origin over to where we meet this blue line. In other words, this red line up here. All right, that is the x value, right? How far away we are from the y-axis. The y value, which is, oh, by the way, the x value is the cosine. The y value is this height right here, which is going to be the sine, okay? And that's why this xy value is the cosine of theta, comma, a sine of theta. But then we have a lot of other measurements as well. For example, this black line or segment right here is going to be the tangent, okay? Whatever the tangent of this angle is. The green line is going to be the cotangent, all right, the length of this thing. The orange one, if you can see this down here, it might be kind of tough to see these colors. The orange one is the secant, all right? So if I did secant of this reference angle, then I would get the length of this line. And then this purple one, this is probably the toughest one to see, but it's from the origin all the way up to meet this green line. That is the cosecant. Okay, so let's just cover those really quickly. The blue line is the sine. The red line is the cosine. The black line is the tangent. The green line is the cotangent. The orange line is the secant, and the purple line is the cosecant. Okay, so now today we're just going to do the sine, which is the blue, the cosine red, and then the tangent, which is black. But I'm going to go ahead and let this thing run, and I want you to imagine that this angle is going from 0 all the way to 90, then 180, then 270, then 360. Now, originally I had this set up so that way it would stop there and then move back, but I changed it so that way it goes around twice, because when we graph these on our new, Cartesian plane, it's going to go forever to the right and forever to the left, right? So it could continuously rotate around this circle over and over and over again. Of course, this is only going to happen twice, and then it's going to rebound and go backwards, okay? And that kind of symbolizes that we can go in the negative as well. So let's just run this, and we're just going to see what these values are. And what I want you to concentrate is, because we're going to start with the sine, I want you to concentrate on the blue line, the length of this, because if we go back to here, remember when I graph the sine of this, the vertical measurement here is going to be the length of that blue line there. Okay, so I basically want to know, like, how high is this going to go and how low is this thing going to go. Okay, so let's go back to this. And so right now, for example, oh, and by the way, this might be hard to see, but the unit circle has a radius of 1, so that means that this blue line, if it gets moved, let's move it over here. If it's at 0, okay, at the angle 0, the length of the blue line is 0. And as it increases, it's going to get bigger and bigger and bigger as the angle increases. Once that angle hits 90 degrees, or pi over 2, whoops, see if I can get it right on the dot. Kind of hard to get. But anyway, that is going to be 1, all right? The height of that is going to be 1, and then it's going to start decreasing till it hits 180, and then it's going to go hit 0 again. And now the length is increasing again, but we actually do use negatives because it's now going below the x-axis here. So this is going down to hit a max of -1, and then it's going to go back to 0. So anyway, so let's go ahead and we'll just watch this thing real quick. So here we go. Watch the blue line as it hits 1, goes back down to the 0, and now it's going to hit -1, and now at 360 it's going to be 0. It's going to keep going, okay? Whatever 360 plus 90 is, then another 90 degrees, then another 90 degrees. This thing's going to keep going and repeat through these cycles, okay? All right. And now it's going backwards, okay? So, all right, so let's go ahead and we're going to stop this thing. And what we want to do now is, actually, you know what I'm going to do is I'm going to bring up another graph, I think. Let's do new blank graph. And I want to show you what this actually looks like before we graph it. So I'm just going to say y is equal to the sine, and I'm going to use x in this case. Again, you can use any variable you want. I'm actually going to use theta in my examples. But here you go. So when the angle is 0, remember the x-axis is the angle. When the angle is 0, the height of that triangle is going to be 0. And then it's hard to tell right here, but I know for a fact that this is actually going to be pi over 2 or 90 degrees. At 90 degrees, it's going to hit a maximum height of 1. And then it's going to start going backwards or go back down to 0, and that's going to be at what we would say pi or 180 degrees. And you can actually see here that it's using pi, it's using radians, and that is very typical. We typically do use radians. So anyway, then once it hits 3 pi over 2 or 270 degrees, it's going to hit that -1, And then finally, once it hits 360 degrees or 2 pi, 2 pi radians, it's going to go back to 0. And so this is actually one full cycle, which will actually give us a period of 2 pi. So it takes us from 0 up to 2 pi, or 360 degrees, to go through one full cycle. So we would say this has a period of 2 pi. Or you could say 360 if you're talking in degrees. Okay, now this can also go backwards, and you can actually see, right, that this thing has a, it definitely has, it's cyclical, right? It's a periodic function. It just keeps going on forever and ever and ever, okay? It just repeats itself. All right, I'm going to go ahead and layer on here a cosine just to see, so you guys can see this. Y is equal to the cosine of x. And this is actually going to look very similar. So here in blue, we have the cosine of x. And I'm just going to go ahead and turn off the sine right now. And remember, the cosine actually stands for the x value. And remember, at the angle 0, the x value, or the cosine of that angle, is 1. So that's why this starts at positive 1. Then once we hit 90 degrees, or pi over 2, the cosine, or the x value, goes back to 0. And then at at pi, or 180 degrees, it goes down to negative 1. And then at 3 pi over 2, or 270 degrees, it goes back to 0. And then finally, at 2 pi, it gets back to where it started, 2 pi, or 360 degrees, which is the same as 0 degrees. It goes back to 1. Remember, that is the x value there, okay? And so a lot of times we say this has kind of like a horseshoe shape, but really you can talk about this in any way you want. You can start wherever you want, as long as you go through one cycle. But this also has a period of 2 pi. It takes 2 pi radians, or 360 degrees, to go through one complete cycle. Okay? And then finally, just so you can be exposed to tangent. Now, remember, tangent, the definition of tangent is the sine divided by the cosine. And there are some issues with this. Namely, sometimes the cosine, the value of this cosine, is 0, right? And if the tangent is sine divided by cosine, and sometimes that cosine is 0, well, sometimes I'm going to be trying to divide by 0, which I can't, right? In math, we cannot divide by 0. So you're actually going to see undefined values here, which will create a vertical asymptote. Okay, so let's go ahead and see what that looks like. If I said y is equal to the tangent of x, there we go. Very interesting graphs here, but actually you can see, at this line right here, this is where the tangent is 0. Okay, I'm sorry, is undefined. Why am I saying 0? So there's going to be a vertical asymptote right here, and we can't cross it. Okay. And then the rest is really just, you're seeing the result of the sine divided by the cosine and the corresponding values. Okay, I'm mostly interested in the shape of this. And I'm also interested, if I turn these off, in the period. So how long does it take for the tangent? We saw the sine and the cosine take 2 pi, or 360 degrees, to go through one cycle. Well, let's take a look at the tangent. And so it's actually kind of tough. I guess it's kind of tough to see here, I suppose. But maybe, you know what? Maybe we can put these on here. Let's see. So where is this going to exist? Well, it's the vertical asymptotes are going to be where the cosine is equal to 0. Right? Because that's where we are going to divide by 0. So let me just single out one of these points. I'm going to do this point on the right. And so where is the cosine on the right 0? Well, in radians, all right, that is pi over 2. So let me just graph that really quickly. I'm just going to say x is equal to, can I do pi? Yeah, pi divided by 2. All right, so there we go. So this is pi over 2. Okay, and you can see this this asymptote, and then I'm going to do this vertical asymptote, and then I'm going to do the negative one over here just to single out one of these cycles. So again, there's a lot of lines on here, but the blue one is the cosine, and that's what we're dividing by for tangent, because tangent is sine divided by cosine. And so over here, where is this cosine going to be 0? Well, it's actually negative 90 degrees, or negative pi over 2. So I'm going to go ahead and make another one here. I'm going to say x is equal to negative pi divided by 2. And then I'm going to take everything else away, okay? Meaning the sine and the cosine, okay? So there we go. And I guess I could change this to purple or whatever, but we'll just leave it as is, okay? So you can see I've got a vertical asymptote at positive pi over 2 and a vertical asymptote at negative pi over 2. And this is going to repeat over and over and over again. So the question is, what is the period of the tangent, of the parent function for the tangent? Well, it's from negative pi over 2 to positive pi over 2, because after that it repeats itself, right? And so what is the domain between positive pi over 2 and negative pi over 2? Well, that's just pi, okay? I've got half of pi over here, I got half of pi over here, so that is pi, or 180 degrees. So that's worth noting, and I'm going to show you later on. We can just calculate that, but the parent functions for the sine and the cosine, the period is going to be 2 pi, or 360 degrees. That's when it repeats. But for the tangent, it's actually half of that. It's 180 degrees, or pi, okay, for its period. All right, so let's go ahead and throw Desmos away here, and let's go to, because really all we care about is the shapes. When we're going to start with sine here, when I start graphing the sine, I'm not going to like plug in all of these individual values. I'm really going to plug in the values that have nice whole numbers, like this 0, 0, right? And then this one right here, which is going to be at pi over 2, it's going to be at 1. And over here at pi, it's going to be 0 again. And then at 3 pi over 2, it's going to be negative 1. And then the rest, as long as I know the shape of the graph, I am going to just fill in or approximate the rest, okay? All right, so let's get to it. All right, so we are back. All right, and so let's go ahead and we are going to graph the sine function. And let's do this. Since the sine is in orange over here, and the sine is literally this y value, I'm going to go ahead and choose an orangish color to do this. All right, and so we're going to get started here. So remember that we are plugging in an angle, and we are going to get whatever pops out of the sine of that angle, okay, for our vertical. All right, so the first thing I'm going to do is plug in 0. So when I'm at 0, when the angle is at 0, hang on one second. Oh, there we go. All right, so I don't know why I couldn't write there for a second. Anyway, so we're looking at this point right here. So what is the sine at the angle 0? Well, that is 0, right? The y value is 0 in that case. So I'm going to go ahead and put in this point at 0, 0. Okay. The next point I'm going to make, and actually I should probably have shown you this before, but we'll probably talk more about it when we do like transformations and whatnot. But the period of this is how long it takes to go through one cycle. And for all of like these trigonometric functions, or at least I should say for the sine and the cosine, it's always broken down into 4. So I know that the graph of y is equal to the sine of, and you could say x. I should really say theta here, but just to show you different variables. The period for this is going to be 2 pi. I just showed you that it's going to be 2 pi. So what I always do is I go out to 2 pi, and then I backtrack and divide that into 4s. Okay, and actually the way I do it is I divide it in half. So 2 pi divided by 2 is going to be pi. And then I go ahead and divide that in half again. So this is going to be pi over 2. And we should know from the unit circle that this one is going to be 1.5 pi, or 3 pi over 2. Okay? All right, so that's really our scale, okay, for our units. And we do need to make sure that we label these first, okay? All right, so anyway, so now I'm going to go to this nice point here, this pi over 2. And so at pi over 2, we're talking about this point right up here at the top of the circle. And so when I plug in the sine of pi over 2, or the sine of 90 degrees, same thing, what is, you get the y value here, which you get 1. So at pi over 2, the sine of pi over 2 is 1. Okay, and then I'm going to keep rotating around, right? So now I'm going to go to pi, and at pi, the y value, which is the sine, corresponds to the sine, is back to 0. So it goes back to 0. 3 pi over 2, right here, the sine of 3 pi over 2 is going to be -1. So we go down to -1. Whoops, wrong one there. There we go. And finally, when we go all the way around and we get back to 360 degrees or 2 pi, the y value again is back to 0. Okay? And so now what I'm going to do is I'm just going to connect these to create this shape that I know the sine function looks like. Now, this represents one cycle, right? Because this has a period of 2 pi. However, what you should keep going, because this thing goes on forever, right? And so I'm going to go ahead and just kind of, I'm going to leave these labeled as is, but I am going to continue this by putting in a little dotted line just to show that this does keep going on forever. And it also goes on forever in this direction as well. This would be negative pi over 2 and back to 0 at negative pi. And we will go ahead and connect these guys as well. Okay, and there we go. There's the graph of the parent function for the sine of x. That's our first trig function. And actually, if you just remember the sine function, then you can do a whole lot of real application work, quite a bit with just the sine. Me personally, I usually use the sine function and don't use the cosine function that much. The reason for that is because the sine function can, or I'm sorry, the cosine function can just be shifted over a little bit and you get the sine function. So you can actually choose one or the other. Okay. All right, so let's go ahead and we're going to do the exact same thing, except we're going to do the cosine now. So let's go ahead and take away the sine, and let's go ahead and we're going to add the sine here. Now, the sine, I'm going to do this in a bluish color to show this value right here because it's in blue. And remember, the sine, I'm sorry, the cosine is the this horizontal distance, okay? And so the parent function is y is equal to the cosine. And again, I'll say x, even though I'm also using theta down here. They both are representing the angle in this case. And so we're going to do the exact same thing. Now, I know that I'm going to start at 0, 0, but I know that this has a period of 2 pi. So I would do this exact same thing where I would go out to 2 pi. I should probably make that smaller. But anyway, and then I am going to go ahead and divide that into 4. So there's my pi. Because I divide it in half. Then I divide in half again to get this guy over here, pi over 2. And then this guy from, what's between pi and 2 pi? Well, 1.5 pi, which is 3 pi over 2. Okay? All right, so once I have my scale worked out, let's go ahead and start plugging in. So the cosine of the angle is going to be the x value, and we're going to start at 0. So at the angle of 0, what is the x value or the cosine? Well, it's 1, positive 1, and that's why we're starting right here. And let's go up to pi over 2, which is going to be this guy right here, and that x value is going to be 0. Let's go to keep going to pi, which is the x value of -1. Let's plug that in here. And we're going to do 3 pi over 2. The x value goes back to 0. And at 2 pi, we've gone around 360 degrees to get back to 0. And the x value is going to be 1. So we have completed one cycle, or one period. Okay? And so I'm going to go ahead and connect these, because I know the overall shape of this kind of looks like a horseshoe. And again, I say in horseshoe, but it really just depends on where you start, right? If you started somewhere else, it would look like the sine graph. Like if I started right here instead, it would look like the sine. But anyways, okay, and so what I'm going to do is I'm just going to complete this because this does go on forever, and I'm just going to complete the pattern. So go back to -1, and we'll go ahead and fill this in with some dotted lines. And I'm going to do the same thing here, because we can also go around in a negative direction, right? Instead of going this way in a positive direction, we could go in a negative direction as well. Okay, and we would get the same values that repeat over and over and over again. So there we go. There's the cosine of x, okay? Or the cosine of the angle, theta, x, whatever you want to call it, okay? All right, so last one here, we are going to graph the tangent. All right, so tangent, I'll just use some other color here. Let's use like a yellow. So this is going to be y is equal to the tangent. And again, to be different, I'm just going to use x here. And so let's go ahead and graph this. This is a little bit more challenging because we have to take the sine divided by the cosine, okay? And so, and I'm probably going to use less points in this case because, I mean, you could use your calculator, obviously, to plug in these real values, but I do know the overall shape of this, and let's just go ahead and take a look at that one more time. Remember, if I turn on the tangent, it looks like this. So actually, what I'm going to do, since I know, specific numbers work out really well, is basically, I'm going to basically take these zeros and then just kind of work the rest out. And I'm also going to do the, or just show you, I suppose, where these vertical asymptotes are as well. Okay, so let's go ahead and we'll get back to our working page here. Okay, so I am going to, I think what I'm going to do is I'm going to use the exact same scale as the other ones just to prove a point, basically. Okay, so let's see here. So I'm going to go out by 2 pi. This one's going to be pi. This one's going to be pi over 2. Okay, and this is going to be negative pi over 2. And negative pi. And here we have 3 pi over 2. And I think that's probably good there. Okay. All right, so let's start at 0, I guess. So at 0, at the angle of 0, we have the sine divided by the cosine. So here we are. It's kind of hard to see there. But sine divided by the cosine. Well, that's 0 divided by the y value divided by the x value, right? 0 divided by 1. And so what is 0 divided by 1? Well, 0 divided by 1, 0 over 1 is equal to 0. I can do that, right? That's fine. It's just equal to 0. So at 0, I have 0, right? The tangent of 0 is 0. Okay, let's hop over to pi over 2. Okay, so pi over 2 is this one at the highest point on the unit circle, and that's 1, 0. So again, tangent is sine divided by cosine, which is 1 divided by 0. Now that's a problem, right? I cannot divide by 0 in math, otherwise you're breaking it. You're breaking math. So we would say this is undefined. Okay, which is why this creates our vertical asymptote. So I'm going to just undo that, and let's go ahead and create a vertical asymptote. It's undefined, so I cannot have a value there. Okay, and let's go to, I suppose, negative pi over 2, which is, let me just erase this guy, which is right here. So if I go to negative pi over 2, it's the point at the very lowest end of the circle, which is negative 1, 0. And again, so that's negative 1 divided by 0. I can't do it, right? Cannot divide by 0. So that's going to give me another vertical asymptote. So you can actually see here that I'm stuck in between these two vertical asymptotes. It's impossible to pass a vertical asymptote in mathematics. And since I know the overall shape of this, now I could go ahead and plug in, specific points. For example, whenever you get to like 45 degrees or pi over 4, you get, pi over 2 divided by pi over 2, which is going to be 1 in that case. Okay. So for example, let me just plug this in. So halfway through here, this is pi over 4, and this is negative pi over 4. Okay, so at pi over 4, well, root 2 divided by root 2 over 2 divided by itself is going to be positive 1. And if I do negative pi over 4, which is this guy right here, kind of tough to see, but that would be the same thing, except now it's negative 1, right? And so it's going to give us this negative 1 value here. And so let me go ahead and I'm going to kind of fill in the rest of this shape. And there you go. There's the graph of the tangent, of one cycle of the tangent. After this, it just repeats. So I can go ahead and just fill this in really quickly. Let's do one more cycle. You can go on the left or the right, but it's just going to repeat over and over again. So in the middle, it crosses the x-axis. Halfway between those two, it's going to be positive 1. Halfway between these two, it's going to be negative 1. And we'll go ahead and connect the dots here in our little, squiggly sine. Tangent function there. Okay. All right, guys. So that's going to be it. We have just graphed the sine. Let's just go ahead and bring these up so you guys can see. So here's the sine. Okay, and the sine starts at 0, 0, for the parent functions at least. Starts at 0, 0, and then it kind of starts the little, snake shape, I would call it, or like S shape or whatever. The cosine actually starts at 1, and then it goes through the same, same exact shape or pattern. But then once we divide, sine by cosine, then you're going to end up with these undefined, these vertical asymptotes. And also, this is going to shrink this cycle in half here, okay, because of that, because it's repeating basically twice over the unit circle between 0 and 360 degrees, or between 0 and 2 pi, okay? All right, guys, so the last thing I want to do is I would like to cover just very briefly, or just show you, I suppose, how we can change these trig functions. So I'm going to go ahead and remove this. And I'm going to bring up, this might look a little bit crazy at first, but I'm going to bring up what I would call the vertex form, or the transformation form for these. And I'm going to bring up specifically the sine, because it really doesn't matter which trig function you choose to use. It's going to apply to all of them. So here we go. Okay, so there's a lot going on here, right? Let's first concentrate on this guy right here, okay? So this is really just y is equal to the sine of an angle. It's just that now I've put in all of the possible numbers that we can put in to change or transform this parent function. So for example, I could put a number out front. We would call that a. And that's going to represent a vertical shift. And let's do that. So a is going to represent a vertical, I'm sorry, did I say vertical shift? Vertical stretch, okay? It's a vertical stretch or compression. And if it's negative, it will flip this over the x-axis, all right? Or reflect it over the x-axis, okay? I just wrote flip here because I didn't have enough room to write reflected over the x-axis. Anyway, here is, actually, let's do all the outside first. So here is this k at the end, so I could add a number, and this is going to represent the vertical shift, okay? So if it's plus 3, it's going to move this whole thing up 3. If it's negative 3, it's going to move the whole thing down 3, okay? All right, let's go to the inside. This b out front here, it could be multiplied into this angle minus a number, but this is going to represent a horizontal stretch or compression, okay? And it's worth noting that this actually has an inverse relationship. So as b gets bigger, it's actually going to compress horizontally. As b gets smaller, and I mean into fractions, then it's going to actually stretch it horizontally, okay? And this h here is going to be the horizontal shift, which it's going to be, again, the opposite. So if it's minus 3, it's actually going to move it to the right 3. If it's positive 3, it's going to move it to the left 3. And there's also another name for this, okay? We actually call this, instead of like when when we're talking about trig, trig functions, instead of saying a horizontal shift, we usually say a phase shift. All right, when you're moving these to the left and the right, we call them phase shifts. Okay. All right, now these all have your normal relationships in any function, right? These apply the exact same transformations no matter what. Um, but we can use these in trig functions to actually calculate certain things. For example, for sine and cosine, this a value, it's actually equal to the amplitude, and it's really the absolute value of a. Okay, you can see here the amplitude is from this midline, which is this blue well, this is a blue line segment, but the midline is really going through the center of this thing at y is equal to 0 in this case. But anyway, so from there you can go up by the amplitude or down by the amplitude. Amplitude is always positive, okay? So it's just the distance to the extremes from the midline, okay? That is the amplitude. Also, we can use b to calculate the period. So for sine and cosine, it's actually the period is equal to 2 pi divided by b. For tangent, the period is pi divided by b, because remember the tangent has half the cycle of the sine and cosine. And k can be used to figure out your equation of the midline. The midline that goes through the heart of this is going to be just y is equal to k, and that's it. Okay, so you have seen all of the parent functions for the three main trig functions: sine, cosine, and tangent. And now you're seeing, well, what if we, what can we add, or how can we transform those parent functions, and what does everything mean? Well, that's what this page here shows you. Okay. All right, guys, so that takes care of graphing the three main trig functions. I know this is a bit of a long video, but, there's quite a bit to cover. So I hope you guys enjoyed the lesson, and I hope I'll see you in the next one. See you guys.